Assalamualaikum warahmatullahi wabarakatuh. Thank you. Cuba nampak sangat bini. I'll start that is for the identity. Start with identity. The identity is pendek, of course. Identity based encryption. Pertamanya saya ingin mengucapkan terima kasih kepada pihak penganjur, Profesor Rizal. InsyaAllah, amin. The title of my talk is Current Trends in Identity-Based Encryption. So I will start with the outline first. I will introduce to you what IBE is, definition of IBE, application, the security properties, and one of the schemes, the first scheme that is being usable, really usable, practical one. Of course, it has its flaws, but I will just go through that one. And the conclusion, I will talk about the a lot of the current trends and what we are going to do for IBE to extend that one to other schemes. Okay, this is the abstract. We'll talk about what is IBE. Okay, IBE is the public key encryption in which an arbitrary string can be used as the public key. This is actually has been going on for quite some time. It's actually started with the history part. Let me start with the history part. The concept was formulated by Adi Shamir in 1984, so it has been there for a long time, 1984 to 2015. The idea came from Adi Shamir, but at the starting of this, basically, the start, how they formulate this one, they feel that, of course, for the public key system, you need to actually manage the keys. That is the problem, and you want to get away with all this key management, where you have to actually build the key, manage the key, produce the key, distribute the keys. And of course, come with the keys are problem with the certificate, where you need to go through doing all the certificate, going through the certificate authority and stuff like that. So they are coming with this idea of identity-based encryption. So it simply starts with this one, to do away with all these keys. But actually in this one, there are also keys, but you do not actually need to sort of bring the keys. So Shamir has this original motivation to start with this IBE, but he actually only give the ideas first. Okay, so he actually only construct this one and then compare it with the existing RSA function. But he was unable to construct basically what IBE is. So from 1984 to 2001, only 2001, somebody named Bonnet and Franklin actually designed their own schemes, and it has been used that for until now. So Bonnet and Franklin, of course, it has its flaws, we will see later, and that is why you are here to design a better one. So the first usable IBE scheme is in 2001. Okay. So from that one, in that year too, another person, Cox, also designed another schemes. Of course, there's a variance, a difference between Bonnet and Franklin and also Cox. One is using in a little bit different. So we come to that one, how it has been being used. So the Bonnet-Franklin schemes has already been used in the one of these security, voltage and security, and has been applied in many everyday usable applications. So that is the idea. We'll see that one. Then on, currently we have what is encryption schemes based on bilinear pairings, and also on the residual assumptions. Then the use of lattices. We'll go through that one on the last page later on. But at the moment, what we have for the practical identity encryption algorithm, we have this Bonnet-Franklin, Sake, and Bonnet-Boyan. The most famous one is Bonnet-Franklin and number 3, Bonnet-Boyan. We'll go through that one. And other IBE schemes. There will be identity-based encryption without random oracles, hierarchical, because they think that IBE is actually not really secure. So they actually improve that one by having a hierarchy. Fuzzy identity-based encryption, and also identity-based encryption schemes without pairings. So that is the history part. You will see that it starts from 1984 and then comes with being usable in 2001, and that currently you have all other IBE schemes. Now, from this history part that we see is currently being developed into some of the certificateless and other variants of IBE. So we go to the definition of IBE first. As you can see, it's a public key encryption in which arbitrary string used as the public key. So you do not actually have the key carrying around you. So first of all, for this IBE, you actually need to have, you need to set up first, initialize all system parameters. Therefore, you need to have an input, a security parameter tree. You need to initialize all these system parameters first. And then the output is parameters, and of course the master key, secret key, master key, not secret key. And then you need to extract, be able to extract, calculate IBE private key from the public key generator. Okay, that would be the private key. So, and the third one would be the how to encrypt that one and to decrypt using the secret key, to encrypt using the public key. So the difference between this one, we will see that for the public key crypto system that we normally do, we actually have the key generations over here, okay, and then we only all part of the key is being used here, generated here. You have the public key and the secret key being here, okay, and then you just use it. So normally the user needs to have all this public key and the private key, and the recipients actually keep its own private key, right? The public key will always be being hanged outside in the public domain. So that would be, it needs a lot of key generations, key management over here. Okay, so for the IBE, it actually solved the problem that you don't have to think much about the key, but still there is a key. Okay, for this one, you actually need to just have go to the key generator, and to get from that one, you just use your parameters, get the parameters, and then you can get your key, and then you encrypt that one, and once the recipients get it, he will just use his identity, box will just use the identity to actually get the private key and to decrypt it back. So you do not actually need to carry around with the public key and the private key. You just need to have your identity retrieved from the public generator. So that is the idea, to actually reduce the cost of this key generation, to reduce the cost of doing this key management. That is the idea to actually solve, the IBE solve that kind of a problem. Okay, so that is basically the idea. So the thing is, Shamir first thought with this IBE scheme to see whether it actually comparable to its RSA. Now if you see here, RSA, basically you have the key generation, encryption, decryption. And this public key and private key is managed by key management somewhere out there. So you have these recipients getting this, having to keep the private key, and the public key is out in the domain. You have to know about that one. So for this RSA, you have this PQ, and normally you have the N, the PQ as a secret key, and so on. And then you encrypt this one using the ciphertext and the decryption. This should be N, right? M equals to C to the power of D, where D is equals to 3, and so on. So it's actually going to be the same way, except that now you will actually have these parameters, N equals to PQ. So these parameters and the master's key are being kept by this public key generator. So you actually, what you do is actually you get the key from them using your own, using the identity to get the key, and then you encrypt and you decrypt. So that is the difference. Is actually you do not need to generate the keys here. It will be done by this public key, by the key generator. So that is the idea for IBE. So for Alice, what she should do is just to, if she wants to send message to Bob, what she should do is just to encrypt, like you are using the email, encrypt with a public key that is really known. You don't really need to carry around. So like sending it to Bob. That will be Bob's email address. So sending it to Bob, Bob will know that that is a message from Alice. With the time, they send all the parameters in. So this public key generator will actually give Alice the identity and to send the message to Bob. Bob will actually receive the message knowing that from Bob he needs to authenticate. He will get this using his identity to get the key from the public key generator, and from that he will actually decrypt it and read the message from Alice. So that is the key server here. So that the problem is, of course, okay, one of the major problems that need to be solved later on is you need to trust this key server or public key generator. That is the big problem. Not the, but actually in this case for IBE, they need a trusted key generator, trusted. So there is no problem if you trust somebody, but if you don't trust that person, the key generator will actually violate it. And that is another case that we don't discuss. Okay, if we don't discuss here, maybe you can in other schemes. So the problem here is you only need a string of parameters from the key generator, and out you can use this one, this IBE. Okay, advantage, disadvantage for you to actually see what's going on. The advantages is you do not need any certificate. A recipient public key is derived from his identity. So there is no pre-enrollment. There is the key expire because when you ask for the key, there will be given 3 parameters: your identity, the keys bag, and the time frames. And the time frames will give you what time is for the key to expire. So you can actually enable post dating of messages for future description. That means you can send the message now, and then it will be encrypted at the date that you actually want. And it also enables automatic expiration, rendering messages unreadable after certain dates. So that gives you the privilege to actually send a message and knowing that you don't have to generate a certain key. So this one is all the advantages. For the disadvantages, of course, these problems keep coming in. That is, it requires a centralized server. Knowing this, people actually develop current variants of IBE because it requires a centralized server. IBE centralized approach implies that some key must be created and held in the public key generator. Therefore, you need a trusted one, and it also requires a secure channel because you keep asking that channel to produce your own keys. Because you're asking parameters and they are giving you back the key that you need to decrypt and encrypt. So you need a secure channel and also a centralized server. So there will be other ways that people can actually overcome this, but that is basically what IBE is giving you the problem, the disadvantages of IBE. Now you come across this one. This has already been used. It's not that kind of cryptography that you just design and not been used. Just like block cipher has been used so many for the commercial parts, where you actually design it to scan certain things to make sure where its location. For IBE, it's being used for encryption. Okay, IBE is only fulfilled for the encryption. Okay, so for this one, what we actually use already being used is for email encryption. This part it actually solved the problem. For number one, it's easy to use. What Bob needs to encrypt message is just to use Alice's email address. Bob can sell mail to Alice even if Alice has no certificate. That is why there is no certificate. Bob encrypt with a public key with the current date, and that gives you something that is the private key is actually short-lived. You can actually expire. That is actually the advantage because the key that you normally have in the normal public key has to be created time over time, right? For this one, you do not need to create keys. Solve the problem of keys. And number 3, credentials. That is sort of easy to grant and revoke credentials of NPKG because when you encrypt, you need some clearance. So Alice can only decrypt if she has the secret clearance on a given date. So that is, she actually needs to have this sort of keys, private keys to decrypt it. So for one to have decrypt it, this one Alice knows that she got the authentication for this part. So number one, the application is for emails users that has been used. Okay. Number two is for web application. We get the receivers, the public key. In a normal PKI server, we store the public key of the receiver in some database. So for IBE, the sender will know only the receiver email ID, and this can be used as their public key. So it will be easy because you only use your normal, as a public key, you only use your something that is very common, something like your address or your name or your email address. So that will be, you do not need to have stored a lot. Another one is for electronic voting. This is normally being done. I think what you did applied for this, I think the recent one is this KWSP voting or something like that, where you actually need to ask KWSP for to register them to get this ID, right? Then from that one, you can actually fill out the forms and then you need to submit it back to them. So they actually use IBE, electronic voting, also in political arena scenario where you can actually use this one, where your name is already in the database, the PKG, so they only need to verify whether you are actually the person. So you need to get the parameters, to get the identity, for you to actually fill out the rights to vote, and then you can submit, and they will count that one to decrypt it back. So for electronic voting, this system has been used, but it's not really, I think there's still flaws in that one. So you need to have some research being done on that one. Some research need to be done on this one. And the last one is, of course, mobile phone calls, because even though some of it is encrypted, there are still rooms of why it's, there are still rooms for improvement. Identity-based proof for the secure channel is actually for some improvement in the secure channel. Some things need to be done for that one to secure the communication channel. So because it's easy for the mobile phone calls, so you do not actually, there are 2 or 3 parts of these cryptographic devices that need to be integrated in the long run. So not just one. So for IBE purposely is to encrypt whatever that you have been sent. So there will be others that you need to add, especially for the authentication. Okay, so that is the application part for IBE. Security schemes. This is to say that how secure is IBE. Of course, this one is, they say the formalization of the notion that no algorithm breaks the crypto system. For that, we have to prove using these challenger and adversary parts. So, I'll skip that one. Okay. What we have is semantic security against an adaptive chosen ciphertext attack. Sorry, HBK. Okay. It's not fully encrypted here. Encrypted here. So what it does is we actually choose this one. Let me just go through this one. Suppose there is a challenger adversary. This one actually perform this IBE. Keep the master key, give the adversary the parameters. The adversary have all these IDs, issue M queries. That means weaving out all the messages. The adversary picks M0, M1 and the public key. The challenger picks a random B. This is a secret code and sends the ciphertext. The adversary issues an additional queries, identities, and the adversary comes with the output B prime. If B is equals to B prime, meaning that you have the same, you are able to pick up this B from the parameters that is given. So then actually beat the purpose of this IBE. But at the moment it has not been, there are some problems to that. So we actually have a lot of security in this IBE at the moment. So we go through this. Now having said about what is IBE, application of IBE, security parts, I'm coming to this part where I'm giving a rough idea about how IBE is being used error start of this one, the first schemes. This will be this Bonnet-Franklin IBE scheme. It has been done, it has been used. It's one of the practical part. Of course, it has problem. But I'm just going to use this one before we come to the current trends. So for the bilinear, what you need to know for the Bonnet-Franklin is you need to have this, knowing this bilinear maps. Okay, that it should be this one, this bilinear maps, cyclic group to a cyclic group of prime order P. G1 and G2 is the cyclic group. So you have these bilinear pairings. Okay, AX plus BY, X and Y is in G1 for all AB in Z step 1. It should be non-degenerated and computable, meaning have to be computable. So in Bonnet-Franklin IBE schemes, you need to set up the parameters first. That means you need to set up the cyclic groups and also this hash function. The Bonnet-Franklin use a hash function on the elliptic curve, on the points on the elliptic curve. So that actually comes up to be the disadvantage for it later on because of the cost of the computation. But as you can see, this setup, you need to have all these parameters. This will be kept in the public key generator, okay, and the master's key. And then you need to be able to extract the identity from that one. The identity is taken from this point S on the elliptic curve with this hash function on the identity. Okay. And then you need to be able to encrypt as usual. Okay, so you choose a random R with the G is this one. G is given to you as a parameter. So then you need to add this plain text with this hash function to get the C. Of course, it comes out as a bilinear pairings. There will be 2 points. And to decrypt that one, the bilinear pairing CUV, you take that V and add that one with the H hash function. And then with the U, you're taking out with these RG parts. So there will be 2 parts. And these ones are proof that is for the Bonnet-Franklin, they took it from the Diffie-Hellman's part, Diffie-Hellman's protocol. So they copied that one and they just choose what parameters to actually play around. Okay. The security function is actually based on this bilinear Diffie-Hellman problem, which at the moment is kind of still strong enough. So the security of IBE. So later on they decide that they are not really that secure against adaptive chosen self-attack attack. And chosen self-attack attack is when they just choose some of the self-attacks and then they come up with the plain text. So from this semantic security adaptive chosen self-attack attack, they try to actually secure it using this technique. Okay, from this technique, they actually try to multiply with this encryption public key PK, and then they will be more secure in this sense. They will have a lot more hash functions embedded inside. Okay, at first you only have 1 hash function, then come up with 2, 3 hash function. So improving this Bonnet-Franklin setup, that will be like this. You will have more hash function instead of 2. Now you have 4. As mentioned before in the last talk, having this one a lot more computation will give you a slower and more costly. That's the only problem with that one. Now we talk about these current IBE schemes that is been going around. Now this is still being used, even though they know it's costly. They know that computing these pairings takes time. Okay, and then this one is also using pairings, which actually takes time. But also because of the computation, for this Bonnet-Franklin, they took it a point and hashed it on the elliptic curve, which actually caused more multiplication algorithms problem. And this one costly, and this one is also using the pairings base. So for other IBE schemes that is being proposed now, one that is very quite popular is this one, fuzzy identity-based encryption. For this fuzzy, this is the current one. Fuzzy identity-based encryption is the one where you use sort of your biometrics data to actually give USD parameters. So what you do is you just like give in, instead of your identity, you are giving in your fingerprints, your as your parameters. Okay, this is fuzzy identity-based encryption. We also developed this hierarchical identity-based encryption. What it means is that instead of one public key generator, you will have to go through a lot more public key generator. It will be the same problem. You will go on as the same problem, but from this one, okay, you will have this recipient identity. You will have a hierarchy of this one, public key generator over here and over here. So that is actually more secure, supposedly, depending on how actually some of the new papers, they combine pairings with some others forms of mathematical tools. Like some in the group theory, some in the complex numbers. So you can actually develop this one using pairings, and another one maybe you can use in other types of forms, in other tools. But the problem over here that is not usable is because it becomes so complicated and it becomes costly. That's the only problem. It can be secured, but it's very costly. Okay, the other part is this hierarchical to perform a lot more public key generator. This one is to have your biometric, which is kind of good for these votings, applied to the votings. And another one is without pairings, because pairing is considered to be costly, but it's actually very secure. So without, you are thinking about without pairings. I have a lot of papers now designed without pairings for this one. Okay. So there are a lot of current trends doing in this kind of research. So the other parts for the current trend is normally based on these three things. This one is the bilinear pairings. Okay, some of other IBE is trying to get away from that one. Some is the use of lattices just to get the parameters, to get the perform their master key. They use lattices. And the other one is actually, this is the assumptions or the residuals assumptions for this one. Yeah? This number one and number two is actually an ongoing research, has been going on since 1980, 2001 till now. Since it has been proposed since Franklin's time, Bonnie Franklin, and this one is Cox. And this one is a kind of a new one, but still I think the idea is not being properly being utilized. Okay, so the last part is this open question on this problem, open issues of why we need to have developed another variants of IBE. That is the authentication of the message received to the PKG, whether the PKG is trustworthy or not. The IB is a stroke system, so it still needs a key, and the key revocation, how do you actually, this is using the expired time that you actually already implemented, but you need to actually solve, actually improve on this one. And the other thing is how you can actually use it in the real world. It has been used, but there are still so many flaws in that. So since the problem was posed in 1984, there have been several proposals, many papers, and if you can see in this one, there have been ongoing research. So there are everything that does supposedly not use keys or not having to manage keys are actually a variance of IBE. Okay, that was all. But before that, I like to put for this one, private key generator. For this trustworthy part, you actually have what is called resilience, anti-leakage resilience cryptography going on and so on. So there are actually a lot of cryptography functions actually being integrated for IBE to improve on IBE. It will not be like the age or any of the first public key crypto system where you only apply using one tools. So, or one like integer factorization or modular expansion or any calculations. For this one, you need to actually integrate a few schemes. There are a few schemes going on that people actually integrate. They so it has in its time is possible. So it's actually like what the other speaker said. If you are so secure, you will have the system will be so slow. But it depends on what you want. For the voting, for example, you need something secured at a certain level, but you actually need it fast so that if you go voting, you do not want the results to be like another 10 years or so, right? So that is a give and take part. Now for this part, I like to summarize that for IBE, it's a little bit different from it's different from the public key crypto systems that's been going on, but it's actually, if you can see, it's how you actually put the keys, how you actually take away from this key management. So there will be things going on. I think this title is a good area for research. Of course, there are a lot of research going on with certificates and everything, but I think this is one where people do not need to actually having problem with this, do away with that one. So you actually need to have information fast. You need to have information that you do not need to carry a lot more information. Get information without needing some information before that. Okay, I like to end my talk here. Thank you.
I have a I want to talk about the application of the IBE, not the scheme one. Okay. Because you already done a lot of, because you are doing the area, right? You have a, like I just Google searching for the thing I want to search. So it's not for my behalf, not for me, but behalf of my friend coming here. When you doing, normally when you talk about the key generation, you have a feature extraction to generate new key. So the idea is that for the medical, you want to extract some features from the human.
Wow.
Okay, yeah. For medical, privacy, this is called privacy.
Of course, it's confidential.
So they want to get
for
some,
any help.
so they have some sensors in the body. You extract the information, for example, ECG, just an example. So you extract some information from your body and then you put part of the key generation. Not just using email.
Okay, that is what is called fuzzy identity-based encryption.
Have you seen something like that during your literature review?
Yeah. There's a lot. Yes. There's a lot, but then people do not, I think in implementation wise, otherwise fuzzy, you know, you like thumbprint biometric cryptography. Then again, it's actually between, like, there are simple, like, people using biometric, like, if you are, this is in terms of storing the data or using the data as a key. Or using the data as a key. So using the data, this is not for storing. Jadi, what it means is that this is a simple thing, similarly with the one using biometric. You're using your thumbprint. Dia ada dua. Satu, people using thumbprint ni just using dia decrypt guna RSA biasa je. So dia buat NQ and then they calculate and then tengok whether tak dia sama tak. Kalau sama authenticate and then you can actually enter the room normally being used. But the other things is that if you want to use that one guna IBE, so it's actually for this one ni kiranya but you need to have the parameter first. So the key generator tu have to be set up first, initialize the parameter first. So then dia jadikan that one as one of the parameters identity dia. So it's very genuine that one. So I haven't seen ini, tapi biometric tu ada we did that. I mean that is a simple thing. So biometric, tapi yang data from you mean that samples of the bilik mayat ke apa itu saya tak pernah buat.
Tak, just about because some
interesting.
It's about VIP people, doctor. VIP people, they have a sensor, they want to privacy their data. So they want to protect. So they don't want, even you go to hospital, they have a very special room, right? Even the Sultan want to have a special room in the hospital, okay, for example. So they want to protect the information because the data being sent to the receiver. Because now they are using they try to integrate everything using biometric and sensor.
Then there is another case of a secure channel. Do you have a problem with the secure channel? Okay, you are keeping the data is of course a problem because you are the even if you store there, who is going to simpan that one? You need to have a trusted one. Number two, you are of course ada secure punya channel kat mana pun. So I think it has to be integrated with other cryptography. But it can be done. But how high is the profile for security? As usual, I said kan yang tadi punya, kalau you go to security, kalau you simpan data terus sangat, it will be hard to retrieve. And when the data is hard to retrieve, it will be jadi harta karun kan.
The issue here because the IP want to use to authenticate user dan sensor and base station. That's the only problem, right? Not just simple one, not the database yet. Okay.
I think that would be interesting for Prof Rizal punya next FRGS project. you apply the FRGS project, get a 1 million, and I'll help you with that. I think problem with the theoretical part, we always manage to get papers. Selamat kan? With the application part, because when we apply a lot kan, we didn't get papers. So kan tu masalah university kan, we don't get papers, we need to get papers. So priority dia kan, in most of our research, you get papers first kan. I think it's a good idea is when you manage to apply. To me, my next.
My friend do PhD. Okay, that's my point.
But I think the apa tu yang paling critical sekarang is the voting, e-voting. The system is dia macam is something like our banking system. Banking system dah lama ada online bla bla kan. But then people need to improve that time over time. Then you ada tag ada apa-apa kan, it keep on going on. So it's the same thing is voting system. Right now memang dah ada, we just kan pergi you just get your ID and proof. Tapi I think there's a lot improvement in that before it can be used really here kan, especially in Malaysia punya.
Okay.
I takut I jadi public generator and I'm not trustful, so masih berjaga. I think what I'm going to say is that the things I cakap ni is hoping that somebody, I'm giving a broad feel kan, dalam dia ada banyak benda yang kena buat. So I hope that I catch your interest in doing some of the little things dalam tu. I just put that lines there because when you want to talk about it, it's quite a lot kan, hierarchical, fuzzy benda tu. Tapi I wish somebody would want to do that and I just assist that one. So there's a lot of things going on with that one. It can't be done alone, it has to be done in a group, and that's why ISPAM is here, I think. So that is the point I'm telling you. And I hope Prof Rizal will get the grants lah for us to work. Okay, terima kasih.
Apa ni? The security depends on the secure channel of getting the private key from the key generator, right?
Yeah, that's
that's the disadvantage.
Yes.
So why hasn't anybody made a proof that the security is reduced to the security of the tunnel? And if the tunnel uses RSA, then the security reduced to RSA again. Nothing, you can't use the identity. So then RSA.
I think that could be the point is the secure channel. But you have to see there are some people who actually malas with the key. Malas dealing with the key, so they do not want to do it with the key. So walaupun the IBE ni guna key, not much. I think you tak payah dealing with the key je kan. That's the point kan. So but there are some people who do not want to do away with that one. Macam lagi pun application dia macam voting sekali je kan. So you don't really want